All right, so how do you deal with these problems in MyOpen Math that deal with proportions and uh, not sample means, not means? So I'm hoping you understand what a sampling distribution is. It's how the sample means stack up around the population mean, and the same thing holds true for proportions. And what we're dealing with is a categorical variable, really. And it all goes back. So what the theory is, what we're trying to do is apply this normal distribution to it. And so what I have here is I have the histogram for a a binomial distribution with only 20 items being chosen, and the probability of success is 0.08. And notice I'm getting a right skewed distribution. Doesn't look very normal. So what if I make this be 40? I'm going to double the sample size. What happens to the shape of the distribution? I notice how the bars get a little skinnier, and it started to, how the mode here, the middle one shifted a little bit to the right, but it's still pretty right skewed. That's only with the sample size of 40. What if I double it to 80? What does that look like? Well, that's starting to look a little more like a normal distribution, but still it looks right skewed. Okay. What if we do, like, I know one of the problems that I was just looking at, math had a sample size of 200. And if you look at that, I'm pretty convinced that that looks like a normal distribution. Okay, notice at the center, I know if you can't, well, it's doing numbers, it's doing not percentage, but if you were to take 15, let's see, make sure I'm not lying here. If I do 15 divided by 200, that's 0.075. So you see how I thought the peak was 15, maybe 16 here? That's 16, yeah, there it is. 16 is the highest bar. What's 16 divided by 200? I'm getting 0.08. So notice the center of this distribution is the 0.08. So even though we're dealing with categorical variables, we're getting a normal distribution. And then this is the percentages, or well, actually this is the counts, but it can also be the percentages, okay? And that's where we're getting the proportions. That's what they're doing in MyOpen Math, and that's where we're gonna go next week when we deal with confidence intervals for proportions along with or tests with proportions along with sample means, okay? So that's what's happening. Now, there's a couple of things that you got to worry about in order to apply this idea that yes, we have a normal distribution, and now we can use all the normal curve tools. It has to have the things you're working about has to satisfy everything for a binomial distribution. And the other thing that works out, you notice how when I increase that sample size, how it got more and more normal. The stipulation is if you take your size of your sample times the probability of success, that has to be bigger than or equal to 10 in order to make this work. And the other flip side of that, you have to take the probability of success minus 1 minus that times, and that also has to be bigger than or equal to 10. If those two situations hold and you have a binomial distribution, you can use the normal curve tools to come up. You can forget all about the binomial distributions. What we have basically is a continuous distribution. So now to go to, let's see here. To go to, let me see if I can't find this question out of MyOpen Math. That's the question editor. Here we go. Now this is the one I couldn't get to work. I don't know what they're doing with that formula down there. But let's go to 16 because that's what some of you asked. Let me clear out the screen. Let's see, how do we clear our annotations? Oh, here we go. Clear all drawings. Let's see. So will it let me do this? Okay, now I'm not getting it to work. Here, let's back it up a bit. So here's my version number 16. So telling me what's the mean of this distribution, what's the standard error? Well, if you go back to the, so I've got 0.47, so the probability of a success of getting let's say voters who support a specific candidate is 0.47, and there's 158 people in the sample, and we want to come up the sampling distribution of proportion. So you see that's an important thing to know, because we're not looking for like how many, we're looking for a percentage. So that tells me that if this is the true proportion of people that support the candidate, that's going to be the center of the distribution. Okay, and we should do that check that I just talked about. If we do 0.47 times 158, well, that's going to be more than 10. And if we do 0.53, because remember it's 1 minus 0.47 times 158, that's also more than 10. And is this a binomial distribution? Well, we have a fixed number of trials. We're assuming that the probability that a voter supports a candidate is 0.47, and that won't change from candidate to candidate. So that's independent. The probability doesn't change. We get a fixed number of trials, and it's a yes/no kind of situation. Either they are going to support them or not. So we've got a binomial distribution. This situation, the sample size issue is correct, all set. So we can apply this normal curve idea to it, though we aren't going to have to do a normal curve. So we know the distribution is basically normal of all these sample proportions. So we're going to go out and we're going to get a whole bunch of different samples of size 58 and 158. And now if you watch that video with Mr. Z, I think his name is, he said, okay, so here's that population proportion. That population proportion they're telling us is 0.47, even though we don't really know that. And then if I went out and did a sample and I got some proportion of people that supported that candidate, it could fall down here, and I could go out and get a different sample of 158, and that could, like, suppose it's 0.53, okay, and that's above it. This one could be 0.46. This could be below it. Okay, but we know that because of the central limit theorem, that these sample proportions, all of them are going to stack up in a normal curve, and the bulk of them are going to be around center around the middle. And if you think about the 68, 95, 99.7 rule, we know that 68% of them will be within certain ranges. This election year, this is a great idea, because this is what they do with the polls. If you think about the margin of error, it's going to look at something we're going to look at in a couple of weeks, but this is where it all comes from. This is why we studied this before that. So how do I get this answer? Well, the mean is always going to be what the population mean is. That's true for sample means and population means and everything in proportions. To get the standard deviation, the standard error, what you do is you take your P, or your population mean, if you know it. Otherwise, you use your sample mean. When we multiply that by 1 minus that population mean, we divide it by the size of the sample, and then we take the square root. So this is how you get the standard deviation, or the standard error, for a distribution of proportions. So to answer this question, I'm going to do 0.47 times 0.53, because it's 1 minus 0.53, or 1 minus 0.47, over 158. And then once you get that answer, you take the square root. And that's what's going to go there. And then, of course, you make sure you give it enough decimal places. So that's the nutshell how to do this problem number 16. I'll show you how to do problem number 17 in another video.